Hi all, let us see sound waves part 3 and it's about Doppler effect. What is meant by Doppler effect? It is a change of frequency occur when there is the relative motion between the observer and source of sound. Again, the source here is not a chili sauce or tomato sauce, is about source of sound. This is the formula of Doppler's effect. The f prime is apparent frequency, v is the speed of sound in air, and f is actual frequency. Positive u0 is speed of observer approaching source. Negative u0 is speed of observer moving away from source. Negative us is speed of source approaching observer. Positive us speed of source moving away from observer. For the case 1, if the source and observer approaching, we're going to use the Doppler's effect formula to find any of these values, possible values in this formula. And beginning, don't worry about the stationary position of source observer. Just concentrate at this numerator to determine the positive or negative sign. When the source or observer approach, it's going to give you positive sign. And definitely for denominator will give you negative. We just follow the flow for this formula, and it gives you new formula as this, where the numerator is positive, denominator is negative. If the speed of the observer is 0, which u0 is 0, u0 here is 0, we will get this formula. If speed of the source is 0, then you're going to put us is 0, then you're going to get this formula. Simple like a bubble without giving you any trouble. For the case 2, we're going to use the same technique that we apply in case 1. When the observer and the source is moving away, by using the Doppler's effect formula, we concentrate at this numerator again to determine the positive negative sign. If it is moving away, it's going to give you negative sign, and definitely for the denominator will be positive. And it forms a new formula which is exactly like this, where the numerator is negative, denominator is positive. If the speed of observer is 0, it's going to be 0, then you will get this formula. If the speed of the source is 0, then you're going to put here 0, and it turned to be this formula. Simple like a bubble without giving you any trouble. Once you understand the two cases, case 1 and case 2 of Doppler's effect, now we can put it into a graphical method for the apparent frequency against distance. How the source when approaching, you're going to put one apparent frequency here, and when it is moving away, you're going to put another apparent frequency here. So these 2 points is apparent frequencies between the actual frequency, and this is the observer. And we have another option of putting the graph into this manner, where f is apparent frequency again, distance, and when the source is approaching, you're going to put one apparent frequency here, and when it is moving away, we're going to put another apparent frequency here. Exactly same like before, with the observer is here. Simple like a bubble without giving you any trouble. To strengthen up our confidence, let us try to attempt the PSPM questions year 2011-12, question number 7A and B, which is related to sound waves. For the section A, describe transverse wave and longitudinal wave. I'm going to give you 2 marks. So transverse wave oscillates perpendicular to the direction of the wave propagation, whereas longitudinal wave oscillates parallel to the direction of the wave propagation. For section B, explain Doppler's effect for sound wave. It is a change of frequency. Occur when there is a relative motion between the observer and source of sound. For B Roman 2, what frequency will be heard by a moving observer traveling at 25 meters per second towards a stationary siren that emits a sound of frequency 280 Hz? Given the velocity of sound in air is 343 meters per second. The question is about the observer traveling towards a stationary siren. So it is approaching. When it is approaching, by using the Doppler's effect formula, the numerator at this portion should be positive and the denominator should be negative. Now we can write the formula as f prime v plus u naught over v minus us times with actual frequency. Again, the observer traveling at 25 meters per second towards a stationary siren. So the speed of the source is 0 and the speed of the observer is 25 meters per second, and the speed of velocity of sound in air is 343 meters per second. So these two values should be 343 meters per second. With the actual frequency of f is 280 Hz. 280 Hz. So you can substitute all the values accordingly. Then you will get the apparent frequency is 300 Hz. Simple like a bubble without giving you any trouble. And for the section 3, sketch a graph of apparent frequency against distance traveled by an object. You have two options to sketch apparent frequency against the distance. You're going to put 2 points between actual frequency, 2 points of apparent frequency, which is the source when approaching. You're going to put one apparent frequency here, and when it is moving away, you're going to put another apparent frequency here. That means you got 2 points which is showing you the apparent frequency between actual frequency. This is the observer. Another option is you can put in this way. So when the source is approaching, you have one apparent frequency. When it is moving away, you have another apparent frequency. Means 2 points here again showing you the apparent frequency between actual frequency. So we answered that part. Thank you for watching this video. Thanks a lot and thank you to the Lord.